The displacement is given by t to the fourth minus 11 t cubed plus 38t squared minus 48t plus 50, where x is in meters and t is in minutes. So it's a distance-time equation. So starting out the same, find velocity and acceleration equations. And acceleration. So, again, doesn't tell you what to do. You've got to know the connection between velocity and distance, and you know that it's the derivative of distance. So go through and do our little power rule. The 4 comes down, so it'll be 4 t cubed minus 33 t squared plus 76 t minus 48, and that goes to 0. Acceleration is the second derivative of distance, or you can call it the first derivative of velocity. Either way, we're taking the derivative of this equation here. So now we've got 12t squared minus 66t plus 76, 0. Okay. Find all values of t for which the velocity equals 0. So we want to know, when does the velocity equal 0? So you are going to set this equation equal to 0. Okay, because there's a cubed, a squared, and to the first power, you can't solve that algebraically. You have to use the calculator. So you want to put that equation in. 4x cubed minus 3x squared plus 76x minus 48. Oops, 48. Alright, I don't know how big my graph is. Let's try to zoom 6 here. I see 1, but there should probably be more. Let me take a look. Table. Nope. Table. Let's see how big the numbers are getting. Oh yeah. The y's. So let's go further out here. Window x to 50. Oh, that didn't work. Where are they? Let me see, did I type this right? 4t cubed minus, oh, see, I didn't type it right. I was going to say, insert 33. I knew something was wrong. Okay, go back to a zoom 6. There they are. I knew there was going to be 3 of them because it was a cubic. So now you just have to get the calculator. It looks like 1, then between 2 and 3. We just got to find those. And those are your zeros. So you're going to go to second calc. And I'll write that on the note so you remember. Calc, zeros. So, second calc, we want to find a 0. And what you have to do is get the cursor before and after each one. Give it that little window. See, right now I'm down at negative 48, so I've got to come higher. So there it is. I've got to be below it. Now I've got to be above it. Get that close to it. So that first 0 is at 1.05. So let's start over again. Second calc, 0. I'm going for this one to be left of it. I got to be above it. Enter. Now I'll get below it. Slide back. 2.37. And then the last one's over there. Second calc, 0. I got to get below it and then above it again. Oh. Below it. Oh. Above it. 4.83. Okay, that was B. Okay, it says plot both. Plot X and V on the same axis. And it says, tell what is true about displacement whenever velocity equals 0. So we've got the 3 spots where velocity equals 0. I want to know what's happening on the original distance graph. So let's go back. We'll put in the distance graph. That's x to the 4th minus 11 x cubed plus 38 x squared minus 48x plus 50. And I'll make this one the fat one graph. Oh, that was cool. It's way up there. So it looks like we have to see up higher. Window. Y max, let's go 50. Okay, there they are. So it wants us to match this 0 with what's happening above it. Oh, look at that. This 0. Oh, look at that. And this 0. Remember, when the derivatives are zeros, that means the original graph had a max or a min. You should be picking up on that at this point. We've gone over that several times. If the derivative is 0, there's a max or a min. So, x has a max or min at the 3 zeros on velocity. Okay. One more. Same idea there with the max, mins, and 0 business. Or no, am I done? I think I'm done. Double check. That. I am done. Okay, your assignment on this section is going to be page 102, 1, 5, 8, 9, 10, and 12. No, missed 7. 1, 5, 7, 8, 9, 10, and 12. That's it.